Now we all know the formula for the classic triangle, right? Finding the area of any triangle is just 1/2 times the base times the height, right? But what if you're given a completely strange triangle like this? That's just a random triangle where there's no clear like base and height, right? I mean, even if there is one and you can find one and it happens to be perpendicular, you have no idea what the base is. You don't know what the height is. You don't know the sides. I mean, like, even if you were given the sides, it would still be pretty tough to know. So that's where our handy Heron's formula comes in. So Heron's formula is this. Formula. It's going to be the square root of s times s minus a times s minus b times s minus c. Now if you're wondering what those are, so a, b, and c, those are going to be the sides, the side lengths in particular. And s is going to be the semi-perimeter. Semi-perimeter. And that means exactly what it sounds like. It's half of the perimeter. Okay, so let's try this out in a problem. Let me just erase all this first. Okay. Find the area of a triangle with side lengths of 9, 11, and 14. So we can tell right off the bat that this isn't going to be a right triangle. It's not any of the Pythagorean triples that we know. And 9 squared, 11 squared, not even close to 14 squared, right? So there's no clear base or height, even if we try drawing it out to the best of our imagination. 9, 11, 14. Yeah, no clear base and height. Okay, so let's plug in our formula. We need S, A, B, and C. So let's find all of those first, and then we'll plug it in. So A, B, and C are going to be 9, 11, and 14. And it doesn't matter what order it's going to be in, just one of them. So I'll put C is 9, B is 14, and A is 11. Okay. And now we need to find the semi-perimeter. So in order to do that, we need to first find the perimeter, which is going to be 9 plus 11 plus 14. And if we want the semi-perimeter, we divide it all by 2. So that's going to be 34 over 2, or 17. So let's write that up here. Okay, so now that we have everything we need, let's go ahead and plug in our handy formula. The square root of s times s minus a times s minus b times s minus c. Okay, so that becomes 17 times, now s minus a, that's going to be 6, times s minus b is 3, and s minus c is 8. Is, oh my goodness, make that back to yellow, is 8. Okay, looks like the square root is actually a little bit longer than I needed to, but that's fine. Okay, so now we all know how to simplify the radicals, right? 17 times 2 times 3, because that's 6, times 3, times 2 cubed, or 8. Now we'll take it out, so we got a 3 outside, and there's another 2 outside, and another 2. So that's 12 root 17. And we're done. So this formula, it's not really taught anymore in curriculums like just in school. Although it's handy to have in school, this is definitely going to come in more useful in the math counts and AMC problems. There aren't going to be like problems exactly like this where it's find the area of a triangle with side lengths of blah blah blah, but it's going to come in more discrete form.